Let's begin this section by taking a look at transfers, one of the most common use cases for Agoric's Orchestration API. Transfers involve moving assets from one blockchain to another, leveraging the unique features of each network. Transfers can be used in various scenarios, such as asset migration. Moving tokens from one chain to another to take advantage of different functionalities or lower transaction fees might be one reason for doing so. Transfers can also be used to facilitate payments across different blockchain networks, providing greater flexibility and efficiency for users. Transfers can also be used to enable DeFi applications to operate across multiple blockchains, increasing their reach and usability. Let's look at a basic example of how a transfer can be implemented using Agoric's Orchestration API. In this example, we use the makeTransferMessage function to create a transfer message. We specify the source and destination chains, the amount to be transferred, and the sender and recipient addresses. The orchestrator.send method is then used to execute the transfer. Transfers are a fundamental operation in cross-chain communication, and understanding how to implement them using the Orchestration API is crucial for developing interoperable dApps. In the coming slides, we'll explore staking and other advanced use cases of the Orchestration API. In this slide, we'll dive into staking mechanisms and introduce the concept of liquid staking. Staking is the process of locking up tokens to support network operations, such as block validation or consensus. Stakers earn rewards for their contributions, typically in the form of additional tokens. Traditional staking involves locking tokens for a fixed period, during which they cannot be used for other activities. Liquid staking, on the other hand, provides flexibility by allowing staked tokens to remain usable in other financial activities. This innovation enhances the liquidity of staked assets, enabling users to maximize their returns. There are several benefits and use cases, including enhancing liquidity. Liquid staking allows users to participate in staking awards while still being able to use their tokens in other financial activities. Increased capital efficiency is another benefit. By keeping staked assets liquid, users can engage in multiple financial strategies simultaneously, optimizing their capital use. And DeFi integration is another potential benefit. Liquid staked tokens can be integrated into various DeFi applications, increasing their utility and value. In this example, we create an instance of orchestration account and use the delegate method to stake tokens to a specified validator. We then check the account balance after staking to verify the operation. Take a moment to review this code before moving on. In this example, the liquid stake method is used to perform liquid staking, allowing the staked tokens to remain usable for other transactions or activities. Understanding staking and liquid staking is essential for leveraging the full potential of blockchain networks and DeFi applications. In the coming slides, we'll continue to explore key concepts and methods of the Orchestration API. Now, let's break down the steps involved in executing a transfer using Agoric's Orchestration API. Understanding these steps is crucial for developing reliable and efficient cross-chain applications. A transfer consists of several key steps. The transfer process begins with creating a transfer message that includes the source and destination chains, the amount to be transferred, and the sender and recipient addresses. In the validation step, the transfer message is validated to ensure that all parameters are correct and that the sender has sufficient balance. Next comes the routing step. The transfer message is routed through the appropriate channels to reach the destination chain. The next step in the process is the execution step. The transfer is executed and the assets are moved from the source chain to the destination chain. And finally comes the confirmation step. The completion of the transfer is confirmed and the recipient's balance is updated. As you work with transfers, be sure to keep in mind the following considerations and best practices. First is security. Ensure that all transfer messages are securely signed and validated to prevent unauthorized transactions. Next is efficiency. Optimize the routing and execution steps to minimize delays and transaction costs. And finally, consider error handling. Implement robust error handling to manage issues such as insufficient balance, network failures, or invalid addresses. In this example, we start by initializing the orchestrator and defining the transfer message using the makeTransferMessage utility function. We then validate the transfer message to ensure its correctness. After validation, we execute the transfer using the send method and confirm its success by checking the transfer status. Understanding the detailed steps involved in transfers is essential for building robust cross-chain applications. By following best practices and using the Orchestration API effectively, you can ensure secure and efficient asset transfers across blockchain networks. In the next section, we will explore key concepts related to the Orchestration API, including interfaces, accounts, and amounts.